It has. I'm lying. Hello everyone, good evening and welcome to our vector algebra section. So in this live tutorial, I'm going to take you through the introduction to vector algebra. We've gone through complex numbers in our previous live tutorial, so in this particular tutorial, we move straight to vector algebra. So first of all, vector algebra. So vector basically is any quantity which has both magnitude and direction. So whenever you talk about a quantity being a vector quantity, we mean that particular quantity has a magnitude. So let's represent it with this straight bar. So depending on the length of this bar, that's what we call the magnitude of the vector. But the direction with which this arrow is pointing to gives the direction of that particular quantity. So a vector quantity is fully characterized by its magnitude as well as its direction. In vector algebra, we have some points of interest which we are going to consider in vectors. So first of all, we are going to consider components vectors. Components vectors. So this is what we are going to start with in this tutorial. So the general notation of vectors is, let's say you have vector A, or let's say vector AB. You put an arrow with a pointed tip, so like this. So this indicates that this quantity AB is a vector quantity and the arrow here is pointing to a direction. Also, a vector can also be represented as a smaller letter, let's say vector A, and with this dwindle on it. So take note of the various representation of vectors. You may not always see this, but sometimes you can see this. Also, vector quantities in a component form, we use angle brackets this way to represent vector quantities, unlike the normal Cartesian component, which is a smooth bracket like A. So whenever you see angle brackets 1, 2, this should tell you that 1, 2 is a vector quantity, and these are the components of the vector quantity. Whilst if you have 1, 2, this is a point in the Cartesian plane. So in the Cartesian plane, a vector can be represented as a line. So let's see. If I have my y coordinates and my x coordinates, if a point in space, let's say point A, 1, 2, if I join it to the horizon to the origin, which is 0, 0, I can get a straight line. This straight line here can be used as a vector quantity in that I would have to know the magnitude from the origin to the point A, and that will give me the magnitude of what? The line. So magnitude of what? OA. whilst the direction here will give me what? Its direction. So making the representation of lines as a vector quantity. So let's see how we find the vector of a line. That is how vectors are represented as a line, and given any problem where you have the components of a particular line, we can find the vector components of that particular line. So let's see. So our first example, it says we should find, so example 1, which is represented by the directed line segment with initial parts, which is point A, giving us 1 comma negative 1 2, then point B, which is the terminal parts. Analyze this problem. It says find the vector which is represented by the directed line segment with initial part A and terminal part B. So to solve this problem, points, let's say it is in the XYZ plane. So let's say something like this. So this will be, so we are saying that find a vector which is represented as this. So I is just a quantity which has magnitude and direction. But now in vector algebra, our interest is always lines and planes. We don't use any other quantity like forces as we use in dynamics. But in vector algebra, it has initial and terminal parts. The initial part, which is point A, has components 1, negative 1, 2. Then the B, which is the terminal part, has negative 2, 1, then 1. So how do we find our vector? So take notes. To find a vector, we simply take our terminal part B minus A, should give us vector AB. So we can also do it this way. So we are saying that vector AB is equal to the terminal parts, which is B minus A, right? So at this point, we just substitute the components here. So B is negative addition, subtraction. You have to make it in a column form so that you get negative 2 here, 1 then 1, minus 1, negative 1, 2. So at this point, what you do is you open up this, and you have minus 2 minus 1, 1 minus minus 1, then the third part is 1 minus 2, right? So this simply gives us minus 2 minus 1, which is equal to minus 3, 1 minus minus 1, which is equal to 2, then 1 minus 2, which is negative 1. So basically, this is how to find a vector which is represented as a line segment. All that you need is and vector B, where my vector A is given as x1, x2, and my vector B is given as y1, y2. If you want to find vector A plus vector B, is simply equal to the sum of the respective components. So you add your respective x values and your respective y values. So I'm going to have my x1, x2 here plus my y1, y2 here. So to sum two vectors is very simple. Just sum the respective components of the vector. So this simply gives us x1 plus y1. Then we have x2 plus y2. If this turns minus, is simply, so assuming we have minus here, this simply gives us x1 minus y1, x2 minus y2. So this is how we go by addition and subtraction of vectors. So let's take some few examples here. So let's see, I have vector A, which is giving us 4, 0, 3. Take note of the angle bracket, which is telling us that this is a vector. Then we have vector B, which is equal to 1, 4, 6, right? So at this point, the problem is find the magnitude of A, find A plus B, find A minus B, find 3B, then find 2A plus 5B. So this is a problem we have here, a basic problem in vectors. But before we do this problem, as I showed you addition and subtraction of vectors, now let's see what we call the scalar multiplication. Scalar multiplication. You know that a scalar is just a quantity which has only magnitude. So whenever you apply a scalar to any quantity, you only magnify that quantity, but you don't change its direction. So assuming you have a vector of this notation and you multiply this vector by, let's say, 3, this vector will continually to move in this direction, but will increase in its magnitude this way. So you can see that it was initially from this side to this side, but after we multiplied by a scalar, its magnitude increased proportionally, but the direction continues that way. So take note, whenever you have a scalar multiplication, let's say I have vector AB, which is giving us A comma B. Whenever I multiply any scalar, say K, multiplying AB, this scalar is going to magnify the magnitude of AB alone, not the direction. So you have something like KA, then KB. So a typical example is, let's say you have vector AB to be equal to 2, 4. So if I apply the scalar, let's say find 2AB. These two here is a scalar and it's going to affect the magnitude of AB. Therefore, I'm going to have two scalar multiplication. So we are going to use this concept to solve the problem we have above here. So let's see. Okay, so let's see the first problem. We have to find the magnitude of A. So you know this from complex numbers, that whenever you see this sign with any quantity within, let's say quantity A, all that it means is find the modulus or the magnitude of whatever is inside. So now what is A? A is giving us so A is giving us 4, 0, 3, right? So we have to find the magnitude of A, and the magnitude of A is simply equal to the sum of the square of each component of our vector. So take note, whenever you have vector in this component, the first one represents the x parts, the second represents the y parts, and the third represents the z parts. So you get to understand this more when you reach the standard basis. So to find the magnitude of A, we simply take the square of each component. That is, we are going to have the square root of x squared plus y squared plus z squared, right? So in our case, we are going to have the square root of the expression 4 squared plus 0 squared plus 3 squared. And that is going to give us the square root of 16 plus 9. which is equal to the square root of 25, giving us 5. So this is the first part of the problem. Then the second part is we should find a plus b. So I have my a here. Let me write my b here. B is equal to 146. So if I have B 146, then to find A plus B, we simply we open up 403 for A plus my B, which is 146. And this is equal to, we add the corresponding component. So X component, which is 4 plus 1, 0 plus 4, then 3 plus what? 6, right? So this will simply give me 549. So A plus B, that is vector A plus B, is simply equal to angle 5, 4, then 9, like this. So these are the basic arithmetic operations we use under vectors. You can do that of A minus B. So for A minus B, we simply subtract the components. I'm simply going to have my A, which is 403 minus 146. So I'll just subtract the respective components. So I have 4 minus 1, 0 minus 4, then 3 minus 6, giving me 3, negative 4, negative 3, right? So angle 3, negative 4, negative 3, like this. So we move on to the third part, which is equal to 3b. So we already know that our b is 146. So 3b is simply equal to 3b. As you know, 3b means scalar multiplication. So you simply multiply the 3 by the respective components. So 3 by 1 is 3, 3 by 4 is 12, then 3 by 6 is 18. And that gives us 3b. Then finally, we have 2a plus 5. 2a plus 5 plus 5b. So let's see. 2a plus 5b. So at this point, I'll have 2. Then you substitute the value of a, which is 403 plus 5, open brackets. You substitute the values of b, which is 146, right? So you apply the scalar first because you have addition. You do the multiplication first. So 2 times 4, which is 8, 2 times 0, which is 0, 2 times 3, which is 6, plus 5 by 1, which is 5, 5 by 4, which is 20, 5 by 6, which is 30. And this simply gives us 8 plus 5, 13, 0 plus 20, 20, then 6 plus 30, 36. So this is simply the basic questions you can be getting under vectors, which will be appearing in your MCQs. So let's quickly go to some few properties of vectors. So I have some few properties of vectors here. So I'm going to get have the properties. Let's quickly go through the properties. So if you have any vector A and any vector B and any vector C, so given these three vectors, then A plus B is always equal to B plus A. That is, vector addition is commutative. Now that is the first property. Then the second property is let's take the associative property, which is equal to A plus B plus C should give us A plus B plus C. So for vector addition, it satisfies these commutative and associative properties. So we also have another property, which is a vector plus its inverse. So A plus negative A is simply equal to 0. So when you take the negative of a vector and you add it to itself, you simply get 0. Then also when you have 1 multiplying a vector is equal to the vector itself. So these are just fundamental properties of vectors which you should know, because sometimes during simplification you tend to meet these stuffs, and if you know the properties you can easily go by them. Then the distributive property, which gives C multiplying A plus B is equal to AC plus BC.